Okay. Well, welcome to another LA Software Craftsmanship meetup. My name is Jamie Isaacs, and code has been my craft for a little over 20 years. I still enjoy learning new things and sharing those things with others as much as I can. And the broader purpose of this group is about sharing the principles of professional software development. Too many of us don't get to develop our craft on the job. And the goal of this group is to learn from each other through skill sharing, mentorship, katas, workshops, open discussions, and talks. So we plan on hosting monthly talks this summer, and I'd like to share with you, we do have a few big names lined up. We have Robert Martin's going to be speaking with us in August. We have him for the 23rd, tentatively. And we have Frances Campoy from the YouTube series Just for Funk. That's a Go YouTube series. And he'll be with us in October. Tonight we have Chris Holland. He leads a software engineering team at a leading HR company. He has held senior engineering and leadership roles for small and large publicly traded companies on a variety of technology stacks, including PHP, Java, C#, you name it, this guy's done it. I got to talk with Chris earlier today, and I asked him what kind of takeaway or challenge would you like to leave the audience with? And this really stuck with me because I use this in my day-to-day life, and that's to ask better questions. Leave today, ask better questions. Come to him and ask him a great question after this talk. In a moment, Chris will be giving his presentation on software development, on taming change. Everyone, please give a warm welcome to Chris Holland.
Thank you. Thanks, Jamie. Okay, does this look familiar? I call it the candid agile stand-up. Right? So welcome to Taming Change, a story of fear and loathing of change and overcoming it in nefarious ways. I think it's important to be able to ask better questions. It's important to look at where we come from and look at decisions that we've made in the past and what were the outcomes, so we can better inform ourselves. So I designed this talk as a keynote. It's got 3 acts. We're going to go a little bit in a little bit of a time machine, yeah, let's get started. So. Act 1, has anybody seen a movie called WARGAMES? All right. Right? Brings back memories? Cool. So, in this movie, they featured a all-powerful computer called the Whopper. War Operation Plan Response. And this computer was able to fire off missiles, because they were afraid that humans would not have the nerve to actually press the button. We actually did not quite build the Whopper, but we built something very similar back in the 50s. It was more of a defensive system. And it was called the Semi-Automatic Ground Environment, the SAGE system. What was it designed to do? The goal was to develop a digital computer that could receive vast quantities of data from multiple radars and perform real-time processing to produce targeting information for intercepting aircraft and missiles. Right? So imagine if a country is throwing a bunch of missiles at you, you want to be able to target them as fast as you can and then still use humans to kind of launch defense systems. So that was the goal of this system. We actually deployed it in northeast of the United States, pretty close to the Canadian border, in a building made up of 4 stories over 3.5 acres. On each story were these machines called the AN-FSQ-7, developed in conjunction with IBM. Each machine had 60,000 tubes and weighed in at 250 tons. And it could process a whopping 75,000 instructions per second. That was a big deal back then, right? Only 250 tons. Oh yeah, and each machine consumed 3 megawatts of electricity. So we deployed 24 of those machines in that building. So I did the math. I was like, hey, 75,000 instructions per second, how does it compare to today's computing power? So that's roughly 0.075 MIPS. So your smartphone with an ARM Cortex A73 processor can do 71,000 MIPS. Okay, so if you do the math, your phone is almost a million times faster than a 250-ton machine. So, and it's pretty fascinating because you can go online and see the entire design and schematics of the system, including operations manual. It's incredible. So I went and dug some of that stuff here. So you see one diagram that kind of shows the flow of data toward the ANFSQ7. Here's a more complex diagram. You can see that there are a few moving parts here. Here's another one. So now this one is pretty cool. If you look in the hands of this dude here, he has what's called a light gun. They invented a technology where you had like a light gun that you could point at a screen to actually control the system. Light gun. And here's a real life dude doing it here. Yeah. So let's look a little bit at the design and planning that went into such a system. So Herbert D. Bennington was kind of the lead engineer on the system. He worked at the MIT Lincoln Lab. And here's the process that they followed. So at the top here, it says operational plan. So they drafted a comprehensive operational plan out of which came machine specs and operational specs, out of which came program specs, out of which came coding specs, and then finally you could get to coding. And then you had to test everything against the specifications as well. Yeah, this might sound a little bit familiar, and we're going to come back to this diagram. So they also looked at the human cost of all this, right? And they were measuring things in man-years. We may laugh now, but some projects have kind of felt like that. So let's not laugh, right? But yeah, they figured minimum production time of 18 months with 130 man-years. So they kind of looked at the cost of things, and they figured out of the initial design of the system that they had done, they figured that they would need a solid 100,000 instructions, and when hiring all these humans, it would cost $5.5 million. So they figured $55 per instruction. When was the last time any of us got paid at $55 per instruction? It's kind of the wrong motivation, right? So what were the outcomes of this system? They actually, instead of 100,000 instructions, they arrived at 500,000 instructions, so 5 times. It was actually operational in the 50s and 60s, and it lasted on and off through the 80s. It cost billions of dollars. It was actually more expensive than the Manhattan Project. Yeah, the nuclear, bomb program. So, and they found in the initial test that it was leaky. It would catch about 1/4 of the targets. It's something, right? It's better than nothing. But they did improve it over the years. So let's go back to this design and planning. This whole thing here. Because it may look familiar. It may look like this, which is the Waterfall Model, right? Which starts with requirements, then design, implementation, verification, and then maintenance. Because you always get to a point where you're completely done with the product, so now you're just kind of in maintenance mode, right? You never improve it. So the Waterfall Model. Dr. Winston Royce first presented it in 1970, and his paper is quite long, and you can feel the conflict that he has, right? Because you can see already that he's already starting to talk about introducing several smaller iterations as part of the discovery phase of a waterfall phase, right? He kind of already acknowledged that, you can't possibly anticipate everything about your system that you can sufficiently architect it in one go, right? There's a lot of discovery that needs to happen. And he called out those challenges in his paper. And then Bell and Thayer, who were working for TRW Defense, they were like, well, let's give this a name. So Winston Royce did not call it waterfall. He just kind of made diagrams that looked like a waterfall, but he did not coin that word. And then Bell and Thayer came in and coined the word waterfall in a paper called Software Requirements, Are They Really a Problem? And then finally, that got adopted by the Department of Defense in 1985. This is how we do software now. So you can see already the origins of the waterfall process way back in the 50s. And it's already enduring in 1985. And when I started writing software in the 90s, it was very much there. In the 90s, early 2000s, I was working at an ISP. Does anybody remember Earthlink? All right. Yeah, they're still around. So I was working there, and I was working on a small feature on a high dollar impact, and we were full on waterfall. And here's what it looked like. Waterfall is all about producing artifacts and documentation. So we had a product requirements document made by the product team, and then they would throw it over the wall to us, where I was responsible for writing a technical implementation document. At the same time, QA would draft a QA testing plan, and then systems engineers would write a hardware provisioning plan. So I'm going to drill a little bit into that technical implementation document, because that's what I knew the most. In it, I put a lot of diagrams in there. Entity relationship diagrams, data flow, architecture. I had a lot of failure modes. We were building a system that was interacting with a lot of APIs, so there are a lot of possible failure modes in there. Database schemas, did a lot of those. Scaling strategies, load estimations, release procedures, because in those days it wasn't quite codified. Logging is a big deal, and also tracking business metrics, right? So I documented all of these things, and as I'm writing about each one of those topics, I'm already thinking of 20 different ways that this could go in practice, right? But I had to document something, so I did it. So this is kind of what the sequencing looked like, right? I would get the PRD in January. I would deliver my technical document in February, start coding and complete coding in May, and then QA in June, and then launch mid-June. We delivered on target, but we were lucky. But if you already look at this, I knew almost everything that we wanted to build well ahead of the PRD being delivered. I could have started coding back in January, but because of the process, I had to wait until May. So we're going to look a little bit at some drawbacks of this approach, obviously. So what I'm trying, when I look back at why we kind of committed so much to this process, and to me, it really felt like what we wanted to do was to commit to artifacts instead of committing to outcomes. And this puts us in a position to say, oh, I'm sorry, if you want to make a change to the system, since it wasn't defined in this artifact, it's going to be new scope. Okay, we got to start over, this whole process over again, right? And if you think about it, what we were doing is we were putting procedural friction around change so that we could limit our collective accountability to outcomes. So we feared change. We feared it a lot. And so how do we mitigate it if we fear it? Well, we do what Elsa did. We froze all the things, right? And that's what we did. We froze changes in requirements. We froze changes in the software design. And we even had code freezes ahead of a release. If anybody here remembers code freezes, those were fun. And to me, writing software in those days felt a little bit like this. It was just not fun, and everything moved at a glacial pace. So obviously, you can already think of some drawbacks, right? You had to define everything that the product should do in your documentation, because if it was not in the initial documentation, it wasn't going to get done. So that introduced a lot of overhead, obviously, and the thing about documentation is it becomes obsolete almost the second that you write it. And you may disagree with that, but by and large, at least my experience is that whenever there's documentation that's written, it becomes obsolete really fast. And so with all this overhead, you're delaying your time to market, which means you're missing revenue, and you're also missing out on learning opportunities, right? When your product hits the market, you can learn a lot about it. And overall, this amounted to a monumental resistance to change. So I think it's important to look at how we were doing software back in the 50s versus doing software in the 90s and even 2000s. So back then, this is how we rolled. Punch cards. So this is like a terminal where we would kind of type out on the punch cards. Yeah. So this is a little bit before Vim, right? A little bit before JetBrains product, right? Here's a punch card. Almost exactly like your ID. So yeah, in those days, computing resources were very scarce, and they were shared. So yeah, you had this massive feedback cycle between the moment that you would write some code and then the moment you would see it executed. And if there was any mistake, it was extremely costly. So we had to plan ahead of coding. There was no choice. And the thing about those days is that, computing back in the 50s was used in some very specific areas. Military, a little bit of aerospace when NASA was starting, social security maybe, but it was not used by, society as a whole. So the computing-driven business opportunities were very limited, and as such, change in those days was not that much of a disruptor. It was actually conceivable to build a system and let it run and kind of be done with it. But now, you start from the late 90s to 2000s, we'd already seen the explosion of the personal computer. You could already have software on diskettes and then CD-ROMs. And also network software. When the web kind of really started booming, you could go beyond the shrink-wrap software and actually go with network software. So now you can update software a lot faster. And then change became practical, and as such, the computing and your software drove your business. And so in those days, you would really shoot yourself in the foot if you were trying to resist change. It was really a bad idea. So what we were doing back in those days is engineering today's systems with the limitations that we had back in the 50s and 60s. So already you could see that there was a problem that was going to happen, which takes us to Act 2. And a little bit of vodka. All right. So we decided to go agile. This is what agile looks like. Yeah, right? So back in the 90s, there were a number of software consultancies that were very successful. They would go to big enterprises, and they would solve business problems for them with software. And they realized that there are a number of things that you cannot tell your clients. You can't tell your clients, I need a full spec for your desired system. I'm sorry, your spec did not include X, so it wasn't in scope, so I'm not going to do it, right? You cannot tell that to your clients. So this is kind of what they would do when you would tell them those things. It's mobster laughing. It's kind of hard to see with the contrast. So pretty quickly, these software consultancies realized the limitations of the waterfall model. And so they decided to fix the glitch, and they came out really strongly with the Agile Manifesto in 2001, and they put it on agilemanifesto.org. So here's what the manifesto said. Individuals and interactions matter more than processes and tools. Working software matters more than comprehensive documentation. Customer collaboration matters more than contract negotiation. Responding to change matters more than following a plan. So that was their way of saying, hey, we're in software and we're here to make you money and we have your back, dear clients. Please do business with us. And that worked really well. So it was in those days that we had this strong recognition that change is software's defining characteristic and that we really have to embrace it. So the thing about the manifesto, though, is that it did not advocate for any specific methodology. It did not advocate for Scrum or Kanban, and it did not advocate for extreme programming. With this said, some of its authors were actually adept practitioners of extreme programming and Scrum. So this Scrum thing kind of stuck. And so when you look at the vision of the manifesto and you look at software today, and you ask of any company, most companies call themselves Agile, so you ask them, what does that mean? What does it mean to be Agile? In my experience, most will say, well, we do Scrum, so we're Agile. We have a CI/CD pipeline. We're Agile. We use an Agile framework. We have to be Agile. It says in the name. So when I ask them, how often do you ship features? That gets uncomfortable a little bit. But they might pivot and say, well, we do about a release a week. Okay, well, are they bug fixes or features? Well, so what happened? There are some realities of software today, one of which is technical debt. I like to position technical debt as artifacts, which make it more difficult to change a system, but the person who actually coined this term is Ward Cunningham. So Ward Cunningham, at the time, worked for a financial institution, and his client saw him refactoring code and asked him, why are you doing this? And he wanted to explain to his client in terms that he would understand, being in finance, what it is he's doing. So he came up with the term technical debt. And here's what he said. Shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with refactoring. The danger, and he used the word danger, okay, let's not, forget that, occurs when the debt is not repaid. Every minute spent on code that is not quite right for the programming task of the moment counts as interest on that debt. Entire engineering organizations can be brought to a standstill under the debt load of unfactored implementation. He said, stand still. To me, this rings really, really true. I have been there, and it hurts. So there are a lot of symptoms that you can observe when it comes to technical debt. I like to boil those symptoms down to an increasing divergence between your business intent and the structure of your code. Okay, and what it looks like is a little bit like this. You have your business, which is heading in this direction, and then you have your software, which is headed in the other direction. And this exponentially growing gap between the two of them is your technical debt. Okay? So, but here's what we did, though. We just kind of ignored this, and we kept piling technical debt, and we latched onto this Scrum thing, and we said, Scrum all the things. We ignored the core problem, which is how we write software, and somebody gave us this Scrum thing, which is a process and organization methodology, which is great, but it still does not address our real problem. So we said, let's Scrum all the things, and everything will be good. So let's look a little bit at what happens when we do Scrum with technical debt. Here's a brick. It is a piece of technical debt. So for a sprint, to ship a feature, all right, we're carrying our brick, and then we're going to run, drop the brick, and then we complete the first sprint. Okay, so I got a brick right here. Okay, so now we're going to do the second sprint. We hold another brick, and so we're going to run, very much trip over that brick, and then hopefully kind of make it to the end of the sprint, right? The tripping that I just did, it's kind of your sprint going from like 1 week to 1 week and a half, because there was a big mess in the middle that kind of tripped you up. And then we drop another brick. So now imagine repeating this process 10 times, 100 times, 1,000 times, right? Imagine how big that pile gets in the middle and how much harder it becomes to get around it, jump over it, right? So this is kind of BDD done wrong. Yeah, brick-driven development. So we don't want to be doing that. So let me ask you this. What happens when we lay enough bricks? Yeah, we get a wall. Now, what happens when we sprint toward a wall? Yeah, let's ask this guy over here. Goodbye. Yeah, it's not fun. And this has been me many times. And it kind of looks like this, right? You're doing your sprint, you're adding technical debt, which adds more unpredictability into the system, and pretty soon your sprint turns into a marathon. Okay? PHP CEO. Yeah. Yeah, anybody saw The Big Short? Yeah, there you go. So, when that happens, are we really responding to change? I would argue that we're not. So, which takes us to Act 3. How can we dig ourselves out of this mess? Which is really the reason we're all here, right? So let's go back to the manifesto and see what we missed on there. There were 12 principles. Now, those 12 principles of the manifesto were not on the front page. They were on a link off of the front page, but we don't really read things. So, but here is the URL with those 12 principles. And among those 12 principles, there is a line which says, continuous attention to technical excellence and good design enhances agility. Technical excellence. Okay, that sounds good, but what does it mean? So I'd like to set the bar as low as I possibly can so that I have a chance of achieving my goals. I'd like to be able to write software that responds to change. And what does that mean? I'd like to be able to add features without breaking things, okay? And I'd like to ship features at a sustained pace. right? Because if I can add features without breaking things, but it takes me 6 months to ship a feature, it's not great, right? I want to be able to have a very decent pace of shipping. So these are the 2 goals that I want to achieve. Not break things and keep a sustained pace. So let's look at the first one, breaking things. I mean, this could be its own talk, but we're just going to look at the surface a little bit. Imagine you're building a large system, and then you're building a component, and then you're adding a few more components to it, okay? And then another group of components, and you can see these intersecting circles represent tight couplings. And when that happens, you get a big mess. And then when you change any part of the system, you run the risk of causing ramifications throughout the rest of the system. And a way to get ourselves out of this hole is through refactoring. With refactoring, we can go from that mess to something that looks more like this, where you have nicely isolated components that are nicely decoupled, and you can change one thing and not break the other things, okay? That's one way to go. So we just looked at breaking things, and we just saw that refactoring kind of helps us not break things. Now let's look at a sustained pace. So we looked earlier at this divergence between our software and our business intent. And we looked at this kind of vicious cycle, right, where you get your marathon, technical debt, unpredictability. So with refactoring, you are now in a position to bring your software from being divergent from your business to convergent with your business. And it kind of looks like this. You would go from this to this. Okay, so now your software structure follows along the lines of your business intent. And again, refactoring is this process. Refactoring is the methodology that allows you to go from here to here. So now you can go from your marathon of unpredictability and get back to a sprint with reduced technical debt and reduced unpredictability. Okay, so that's the 2 things that I like to keep in mind when it comes to achieving technical excellence. And we just saw that refactoring is a big enabler of this. So now let me ask you this. Why do we not refactor? Okay, we got to build new features, absolutely. At the core of it, though, anytime I refactor code, and I think this describes it really well, when you find an old piece of legacy code buried deep in your code base and you try to delete it, yeah, I know. We're afraid of breaking things. I mean, sure, we have this constant, pressure to build new features, but there are a lot of refactoring decisions that we could make that we do not make because we are afraid of breaking things. We don't know how much regression testing we need to be doing to really properly verify that we did not break things. So we fear change. So how can we alleviate this fear of change? Because it is 2019 and we still fear change. I'm interested in not fearing it anymore. So in my experience, 3 things have worked really well for us. Patterns, clean code, and test-driven development. So patterns are going to allow you to start out with a system that stays more closely aligned with your business intent. It will allow to simplify the complexity of your system. So you get patterns and principles. It could be the solid principles, the gang of 4 design patterns, Fowler's patterns of enterprise architecture. If you're into functional programming, Scott Vlashin has a great talk on functional programming patterns as well. I have a link to that here. That's what that link is here as well. And then clean code, it's code that is going to read like English. that you can reason about a lot easier. That's going to be a lot easier to refactor. And so I have a link to Uncle Bob's book on clean code right here, but you can't see it, but it's right there. So now I want to touch on test-driven development, because of those three things, test-driven development is what has had by far the highest impact. And the thing about it is, it allows you to get into a very efficient workflow, where all you do is you write a small test first, then you write just enough code to make the test pass, and then you run your test suite, and that's it. So there's no overhead of clicking around the UI. You really stimulate your code with your test. And as you introduce new features, you're going to introduce refactoring into the process, and refactoring is going to be baked into the process. And you're not afraid to refactor, because your tests have your back all the time. Okay, so no matter how many features you add to your system, you can settle into this workflow, and it constantly helps you improve the code. Refactoring is really part of the DNA of TDD, which is what makes it super efficient to write better code. So yeah, TDD embraces refactoring. So refactoring gives us software that responds to change, such that we can add features without breaking things and ship features at a sustained pace. And to be able to do refactoring without fearing things, these are the things that you can do, and especially test-driven development. All right? So these things have worked really well for us, and whenever we can do all this, we feel very excellent. So if you want to learn more, and if you want to put your kids to sleep, or if you want to put yourself to sleep, I have 7 hours of video on YouTube of me doing live test-driven development. It's all there, so you can check it out. It's like 6 or 7 videos between 45 minutes and an hour. I have a link here to Uncle Bob's Clean Architecture article, and then his book that came out recently, and also his Clean Code book. So if you're interested in learning more about the essence of object-oriented programming, I really like talks by Sandy Metz. They're phenomenal. She comes from a small talk background, and it really helps us think about things differently, and so her talks are great. Anjana Vakil, she has a great talk going over the history of various programming paradigms. It's pretty fascinating. If you want to know more about technical debt, Doc Norton has a great talk about that. And if you are dealing with legacy code and you want to wrangle it, Michael Feather's book on the subject is great. And if you're interested in design patterns, that's in PHP, but yeah, you can apply them to any language. So I just showed you some of the things that have worked for us, but your journey may differ. The thing, though, the stakes are really high, because software does drive everything. If you think about banking, healthcare, finance, software drives all of that. I mean, you were in healthcare here at PatientPop, right? Travel, entertainment, communications. This is where it gets creepy. Home automation, alarm systems, fire detection, surveillance, military, aerospace. The Boeing that, the MAX that crashed, right? That was bad software. So we're getting to a point where, as Robert Martin predicted for years, that software can't actually kill people. But if you think about it, Tesla has been putting software into their cars, right? Automated driving. And you might ask yourselves, what could possibly go wrong? I don't know, this. That's a Tesla crashed at a Tesla dealership. That's super meta. So if we look back at all this, what we did from the 50s to the 90s, what we did was we wrote change-resistant software, because we started out with punch cards and lower-level systems, around which we built change-resistant processes like the waterfall process, around which we built change-resistant organizations, very siloed organization. And then in 2001, we said, we're agile now. All right, what does that mean? Well, we built Agile Teams, around which we aligned them around agile processes like Scrum and Kanban, but we still wrote crappy software. Okay, so now let me ask you this. What happens when the outer layers put pressures toward that inner layer, right? The inner layer fights back. It starts to vibrate a little bit, which makes your whole agile process, mess up as well. And then your whole team just kind of blows up. And then when that happens, yeah, it's not fun. I know. And this is what we keep doing over and over, right? This is why I want to go back in history, because, we laugh at new programmers who do this, right? But we think we're experienced programmers, and we keep, stepping onto that rake with a much fancier pattern. We need to ask better questions. What we need is technical excellence in our software. Because then, it makes complete sense to align ourselves with around Scrum and Kanban. And then it makes complete sense to have Agile Teams. That's what we need. Because yes, change is coming. So this is what we got to ask ourselves. What technical excellence means for each team. It should be one of the very first questions that an Agile team asks of itself. What does technical excellence mean for us? And in the end, we want to be able to engineer agility into our software. So we looked at the impact of change in business and the impact that it has on change in software and how we can get the two to align better, right? But it's 2019. Why are we really asking these questions, now? I mean, we have been for, some time, but, by and large, you look around, bad software is being written. So I think it's important to have a bit of a change in perspective. And to do this, I want to do a little bit of a post-mortem. Sorry, I mean a retrospective. That's the Scrum parlance. Sorry. We don't want to be looking at a dead horse, right? So it's a retrospective. And I want to ask ourselves, how did we get here? How did we spend decades not addressing the core of the issue, especially since 2001, when we say, hey, we're agile now, and we roll with Scrum without addressing technical excellence? And it comes down to asking better questions. But I think there are many factors that prevent us from asking better questions, but one of them, I think, is a lack of diversity of thought. We need that, and often we don't have that. And what does that look like? So I've been at a table like this. This is a round table where we ask ourselves, how do we shape business value with software? And you have a highly represented person, looks like me, right? With a bunch of other people around the table that look just like me, right? And then somebody goes, Scrum is everything. Okay? And everybody will be like, okay, sure, Scrum, yeah. Okay, why not? Sure, I guess. Harmony, right? Let's all think the same. So this is where groupthink comes into place, and it's a very interesting phenomenon. And I've been there. I've been one of the persons at the table, not raising my voice when I had a concern. And it kind of looks like this. It occurs when a group of well-intentioned people make irrational or non-optimal decisions that are spurred by the urge to conform or the discouragement of dissent. And it's basically going with harmony and coherence above rational thinking. That's kind of what groupthink is, okay? Now, what's an HRP? Yeah, highly represented person. Okay, me. And so I'm at a table with a bunch of me's around the table. And, how did I build this table? How did I build this team, right? Well, similarity bias kind of comes into place, especially in hiring, right? I am more likely to hire people who think like I do. And it kind of looks like this, right? Me, me, me. Me too. Right? And then next thing you know, I'm just kind of looking around, so, oh, a bunch of me's everywhere. Awesome. So psychological safety is another big factor that kind of goes into this, right? So there's a great article by Amy Rigby on the Trello.com blog that kind of explores psychological safety. But basically it kind of looks like this, right? Nobody wants to raise their voice in a meeting and be the lone dissenting voice. So we all look like Jerry Maguire going, who's with me? Who's with me, right? Nobody wants to be that person. And so psychological safety is to make an environment that is conducive to somebody bringing up an opinion that is not aligned with the group. So how can we turn it around? Let's look at that same table again, where you have your highly represented person, and now you start hiring people who don't look and think the same. And now when one person goes, Scrum is everything, and the other cheerleader is like, yeah, sure, okay, Scrum is everything. Well, now you start having a little bit of a, different questions being asked, where somebody might ask, what about technical debt? Okay. Yeah, what about software quality? Should we look at extreme programming as well? Which then encourages other people in the room who may have thought along the same lines to be like, yeah, this whole technical excellence thing, that was on that Manifesto thing. Yeah, okay. So now the whole dynamics of the group change. And there have been a number of studies on this. So here's an article by Anna Johansson that looks at workplace diversity to diminish groupthink. And then here's an article on the Harvard Business Review that shows that employees of firms with diversity are 45% likelier to report a growth in market share over the previous year and 70% likelier to report that the firm captured a new market. Again, it's not a guarantee that you will, but your odds increase, right? So if I'm running a company, I want to stack the odds in my favor. And then here's another study by McKinsey that calls out very similar findings as well. So yes, there may be something to this whole diversity thing, but how? And I think it's important to look at what the glitch is, right? And I kind of explore what the problem is so we can try to solve it. So I went to look at the Bureau of Labor Statistics, BLS.gov. They have all kinds of stats on there, pretty fascinating. And here's what it will show you. Here's your general, it says general workforce, where you have 46.9% of women and 53.1% of men, so roughly equal. And then here's the breakdown of minorities. So Hispanic, Latino, 17%, Black, 12%, Asian, 6%, and then here's the rest of the breakdown. Okay, and then whites are 62%. So if you look at all this and you isolate to white men are only 33% of the workforce. That's all we are, okay? So, and yet, when you go look at the Government Accountability Office, which shows the ratio of male versus female workers in tech, and the ratio of whites versus everybody else in tech, you can see a very strong dominance of white male, likely upward of 70%. So yeah, white men are over 70% of the tech workforce. So here's the thing, we're not diverse. And yet, the talent pool is clearly there. And we really should be leading other industries on that because the barrier to entry is very low, at least in software engineering and many other tech areas where a college degree is not necessarily required. And now, there are so many affordable learning options. There's never been a better time to become a software engineer. So why are we not leading? And it comes down to the privileges of the few and the exclusion of the many. So here's me. I'm male. I am white, cisgendered, straight. I have full use of my legs and arms and hands. I have full use of my eyes and ears. And I am neurologically average, so I don't have to deal too much with stress, anxiety, depression. I just kind of bottle all that up, right? But these attributes, we live in a world where these attributes make me extremely privileged. And here are a number of things that I don't have to worry about. I worry about them for other people, but these things do not impact me personally. I'm not worried about being harassed sexually, verbally, mentally. My safety in public transit. Stairs, inaccessible buildings, websites with poor contrast ratio. Having my opinions, abilities, and expertise unfairly second-guessed. Unfairly second-guessed, right? I get second-guessed all the time, but it's fair. Others taking credit for my work. That pretty much never happens to me. Being unfairly disqualified when applying for a job. Being unfairly excluded from promotions. Gender assignments on bathrooms. I don't have to worry about those things. And again, I don't deal with stress, anxiety, and depression because it's all in the bottle, so it's safe. So here are some things that you'll find online. You may think that these behaviors, like, who does that these days? But it's a very much a reality of many folks who are not like me. This was a job listing that called out preferably Caucasian. Yeah. Here's a tweet from a recruiter who says, "Oh yeah, I've been told we have a dark problem, or only submit Tom and Dave sounding names. As a woman of color, I was outraged and stopped working on those clients immediately." That was from April 2019, this year. Okay, these things are real. They happen to a lot of people every day. Here's my good friend Jenna Hilferty. This is a tweet that she did a while back. These are things that she's heard throughout her career. Just give up. That's a man's job. You're fired. You can't. Your anxiety makes you weak. Stay in your lane. It's impossible. Back off. Stop caring so much. Maybe tech isn't for you. Well, we were able to recently hire her, and she's absolutely kicking ass. And this is what she's telling them now. So if you're interested in learning more about these topics, I recommend Merlene Raymond's talk. She's going to be speaking about inclusion at Cascadia PHP conference in Portland. I have a link to Jennifer Wadella's talk with John Skeet on the subject. Really good talks. So, we may call these things bias or whatever, acquired learned behaviors. These are all choices that we make to make this world around us. So we can choose to exclude we can choose to continue to exclude the 67% and keep laying bricks because we're not going to have enough diversity of thought. We're going to keep asking the wrong questions, and we're going to keep doing the same thing we've been doing for decades. Or we can choose to include the 67% and actually have a shot of greatness. And speaking of greatness, remember the 50s when we started out this talk, and Fortran and punch cards These technologies were used for this little thing called the space program, the 50 space program. And so we were super excited to launch dudes into orbit. We could do this all day. But we had no idea on how to get them back. Whenever we asked that question, it was like, well, a black woman figured it out, Kate Johnson. She worked for NASA at the time, and in a room full of male engineers, nobody could figure out how to calculate the trajectory to get somebody safely back to Earth. She figured it out. It's almost like she had to invent new math. And in those days, Fortran computers were starting to be used, but they would not trust those computers. They would make sure that all the calculations would be validated by her first. So astronaut John Gray was like, look, I love your computer, but I don't trust it. I will not go into space unless Katherine Johnson validates the calculations. She will be 101 years old on August 26th this year. She is still around. Yep, absolutely. Yep. And here's Dorothy Vaughan. That she's her contemporary as well, working for NASA. And Dorothy was, she pioneered Fortran development on IBMs. She managed to get her hands on documentation that she was not supposed to get to kind of learn how to do Fortran, and she taught herself and many other black women how to do this, and she and her team outperformed every other team. And what she recounts was that she said we had to achieve twice as much to get half as far. They outperformed all the other teams, but they only got a fraction of the recognition that the other teams would get. She said, we changed what we could, we endured what we could not. Imagine these minds if we had properly unleashed them. So, yes, Hidden Figures, the movie, but it was the book by Margot Lee Shetterly. The movie took some liberties with some things, right? There was no smashing of the bathroom sign. Katherine Johnson actually ignored the bathroom sign. But yeah, a lot of the things definitely ring true for sure. So if you're interested in learning more about women in computing and in computer science, there's a series of great articles called A Computer of One's Own. And you'll learn about Barbara Liskov, Grace Hopper, Margaret Hamilton, and well over 24 other women who were foundational to computer science. All right. So, if I put you to sleep, and you're just now waking up, right? We looked at how we made mistakes. And so, I think that the biggest opportunity that we have to put ourselves in a position to ask better questions is to seek out diversity and promote inclusion. At this point, we will be able to more reliably define what technical excellence means for us, so we can stop laying bricks. And we can actually truly respond to change to the business that drives software. Sorry, to the software that drives business. All right, that's all I have to say about that. Thank you so much for your time. I appreciate it.